we'll be discussing in this lecture is TCP over 2.5 and 3G wireless networks. So, so, so the 3G wireless network, the data rate of the 3G wireless network will be up to 64 kilobits per second, and and it will have, so that is during in uplink it will be up to 64 kilobits per second, and in downlink it will range from 150 to 384 kilobits per second. And most often the data rate will be asymmetric. It will vary between uh, 3 to 6 times. It may not exceed 3 to 6 times. Okay. Uploading is limited by limited battery power. In cellular networks, asymmetry does not exceed 3 to 6 times. Considering broadcast system as additional distribution media, asymmetry may reach a factor of 1000. Okay. Serious problems that may reduce throughput dramatically or bandwidth oscillations due to dynamic resource sharing and all these things. So generally, the wireless links experience high latency, high jitter, and packet loss. So considering all these things, these following suggestions were made. That is, to set up the large window size initially. TCP should support large window sizes based on the bandwidth delay experienced in wireless system. Okay, with the help of large window size and large buffer sizes, this can be accomplished. A larger window of 2 to 4 segments may increase performance, particularly for short transmission. The another suggestion is limited transmit. So this mechanism is defined in RFC 3042, is an extension of fast retransmit or fast recovery, and is mainly useful when small amount of data is to be transmitted. And also it is suggested to have a larger MTU. The larger the MTU, the faster TCP increases the congestion window. Okay, and and the MTU path discovery, according to RFC 1191, should be used to employ larger segment sizes instead of assuming smaller default MTU. Okay. MTU is maximum transfer unit. So the maximum transfer unit, if it is increased, then the link layers need not perform fragmentation. All these things will be reduced. Okay. So so these are some of the suggestions considering the wireless networks, how TCP should be fine tuned. So this is called as fine tuning the TCP. And then TCP should support selective acknowledgement. It should also support explicit congestion notification. Because whenever there is a congestion, it should be informed so that TCP can behave appropriately. And timestamp should be included. This TCP connection with large windows may benefit from more frequent RTT samples. It is RTT is round trip time. So based on the round trip time, the TCP can adopt its behavior. Okay? And also it is suggested not to have header compression. This TCP header compression mechanism, according to RFC 1144, does not perform well in the presence of packet losses. So this mechanism should not be used. Header compression, according to RFC 25007 and RFC 1144 is not compatible with TCP options such as the selective acknowledgement or timestamps. So these are some of the suggestions so that TCP will perform better in wireless networks, right? So that's it about mobile transport layer. So with this, we are stopping this chapter, stopping this session. A brief summary on this. So we have discussed what is traditional TCP, how traditional TCP works, why traditional TCP cannot be used in a mobile network. Okay. The problem with the traditional TCP is it always assumes congestion when there is a packet loss, and it will go for slow start But this is not the scenario in a wireless network. In a wireless network, the data loss may not be always due to congestion. It may be due to several other factors, because of the inconsistent wireless links and due to interferences, and there are many other reasons. So we have discussed several classical TCP improvement techniques, so that the TCP will perform well in wireless networks like indirect TCP, snooping TCP, mobile TCP, fast retransmit and recovery, selective retransmission, transaction oriented TCP. All these things we have discussed, and then we have discussed how TCP can be improved by fine tuning certain parameters so that it will work better on 2.5 and 3G networks, right? So this session particularly concentrated on TCP. Basically, there are two main protocols in transport layer: TCP and UDP. But we need not perform any changes to the UDP. UDP as such, it will work well in the mobile networks. Whatever the modification that is done in mobile IP, that is sufficient for UDP to work. But that is not the case with TCP, because TCP tries to provide reliable data delivery. So TCP is bit complex. So some improvements are required in TCP so that it will perform mm, better in the wireless scenario. So in that context, we have discussed this session. Right? So let us stop here. Thank you.